So in this video, we're going to look at task 8, curves, polygons, circles, and triangles. This video specifically is just going to focus on the curves. So curves are figures in the plane that are not linear. Certain letters of the alphabet would be curves, think S. However, curves can also be made up as groups of segments connected together. So for example, like this is a curve, or it could be a bunch of like straight segments. Like this is a curve. So those are example of curves. Or something like this is a curve. Okay, so we consider all of these curves in geometry. So we have first two types of curves. We can consider them connected or not connected. So these three that I already drew are all examples of connected. Again, a connected curve is just one where there's no breaks in it. So that would be connected. A not connected would be like if this was our entire curve or something, like if this represents our entire curve. And there's pieces of this curve that are not connected. And then we have a simple curve, and a simple curve does not intersect itself. So like these first three that I made would be a simple curve. These two would be simple curves, but this one would not, because it has this like intersection point here. So again, if we just do an example of a simple curve, and like this, like a triangle is also considered a simple curve. It's considered not simple if it intersects sometime like within the curve. And then we have a closed curve. So a closed curve starts and stops at the same place. So for example, this is a closed curve. The triangle would be a closed curve. It stops and starts at the same place. A not closed curve would be most of the other ones that I drew. Something like this, or again, it can be something that intersects itself, but there is a point where it does not stop and start at the same place. So we have all those definitions to kind of work up to the main term that we are going to use in this class, which is polygons. So polygons are simple closed curves with only segments as sides. So you know polygons as like a triangle or a square or a hexagon and a trapezoid. These are all example of polygons. Okay, so they're closed. They like start and stop at the same point, and they do not like intersect themselves anywhere. So then we have curves that are either convex and concave, and we usually classify polygons as one of these, convex or concave. So convex curves are simple and closed, such that the segment connecting any 2 points in the interior of the curve is wholly contained in the interior of the curve. Okay, so what does that mean? So if I look at a triangle, if I were to pick any 2 points on this triangle and would connect them, that segment has to be completely inside of the triangle or on like the edge of the triangle. So this is considered a convex polygon or a convex curve, because any point that I would connect between those two would have to be inside the figure. Okay, same thing with like a square or a rectangle. any 2 points that I pick. It doesn't matter if I pick 2 points here, or I pick a corner point and a non-corner point, or if I pick 2 corner points. When I draw a segment between those points, it is going to fall completely inside the figure, or it's going to be like the curve itself. Versus a concave curves are not convex. And so a segment connecting any 2 points in the interior of the curve is not wholly contained in the interior of the curve. So if I have this curve, if I were to pick 2 points, so if I were to pick like this point, and I drew my segment, yes, that would be inside the curve. But it is concave if there exists 2 points that if I pick them and I connected them with a line segment, there would be no way that line segment could be completely inside this figure. And so if I were to connect these 2 points, and that's not a very good straight line, so let me fix that. This point and connected it, that line is not completely inside of this figure. So again, if I picked like this point and drew a line segment connecting them, this line segment partially goes outside the figure and is partially inside. For it to be convex, the line segment has to be completely inside the figure. Right? And so this is an example of a concave curve. So just to show you kind of the groups, these ones here are convex. So A is convex and B is concave. And again, because if I pick like any 2 points, wherever I pick, if I connect them with a line segment, that line segment is going to be completely inside the figure or the curve itself with any of these. And you can pick any 2 points. And if I connect them, it's going to be fully inside of that figure. Same with the triangle. But for these, there exists 2 points somewhere in this figure that if I connect them, my line segment is going to be not completely inside the figure. Sorry, I am not the best at creating line segments. Okay, so these are all concave. And so that's the difference between convex and concave. Okay, so for an example, we're gonna put a check mark on all the appropriate columns that apply to the figure to the left. So I would recommend like pausing the video, reading through the definitions again, and then trying to check these off, and then coming back and watching my explanation to check if that you got this right. Okay, so this curve, let's just go through all these and we'll say, are they simple? So remember, if we go back to our definition, because simple curve does not intersect itself. Okay, so this one does not intersect itself. This one does not intersect itself. This one does at this point, so that is not simple. This one does not. This one does not. And same with this one does not. So the only curve that is not simple is this third one. Okay, so then the next column is a figure is closed. So if we go back, a closed curve starts and stops at the same place. Okay, so we're looking at this one starts here and stops here, so that is not closed. This one starts here and stops here, so that's also not closed. This one, I don't know, whatever point you pick, it starts, and if you trace the curve, then you would also stop there. So this one is closed. This one is also closed. Same with the last two, would also be closed because they all start and stop at the same point. You could pick one point and trace the curve, and then you're going to get back to that point. So then our next column is polygons. And so polygons are simple closed curves with only segments as sides. Okay, so if we look at this, this is not a segment, so that is not a polygon. This one is not closed. So both of these columns, because the part of the definition was it has to be simple and closed, have to be checked for us to check the polygon one. So this one is completely out, and so is this one because this one is not simple. Now these are simple and closed, so then we have to check are the side segments, and this one is not. This is more like curved. This one are all segments, so this one is a polygon, and this one is all segments, so this is also a polygon. And then we have convex and concave as our last two columns. So again, convex means it's simple and closed, and we can connect any two segments. And that line segment that we connect it with is completely inside the figure. Okay, a concave figure, again, is also, if you want to add this, simple and closed, but it's not convex. So when you can find a line segment connecting 2 points that will not be completely inside the figure. So again, we're only looking at the simple and closed ones. So we're looking at these last three. If it's not simple and closed, it cannot be convex or concave. So this one is simple and closed. And if I pick any 2 points and connect them with a line segment, that segment is going to be inside of our figure. So as a result, this one is convex. Same with this one. Any 2 points that I connect, I'm either going to be inside the figure or I'm going to be completely on the curve. So that one is also convex. But this one, if I connect like these 2 points or these 2 points with a line segment, my line segment is pretty much outside of the figure, completely outside the figure. And so this one is not convex, and therefore it is concave. So those are the definitions with the curves. There'll be a few questions on the homework and on the exams about which type of curves they are. But otherwise, we're mostly going to be here building on the foundation of a polygon. So that's the really one that you want to make sure that you know.